All right, guys. So we are going to shift gears. On Friday, you took your comparing fractions assessment, where we looked at which fractions were greater and which fractions were lesser. Now we're going to spend some time focusing on when fractions are equivalent or equal to each other. Okay, how do we determine if a fraction is the same size, and how do we create fractions which are the same size? Okay, so that's what we're going to take a look at today. I'm going to ask you to please go to your Seesaw and click on that activities bulb to refresh your feed. When you do that, you're going to see an activity called Equivalent Fractions Exploration. That's what we're going to work on together today. There are 17 slides. Half of them we're going to look at together, actually more than half of them. And then the less than half, you are going to work on independently today during your work time. I want to remind you that there are no office hours, but this assignment has been modified to be pretty straightforward in terms of making sense for independent work. So you should not need a lot of support on this, especially if you are focused in on what we're talking about. Okay. So if you would, please go ahead and click Add Response. We're going to look at that success criteria. And then we are going to take a look at a vocabulary on equivalent fractions to kind of give your brains some visuals and some vocabulary words that are going to be helpful to you with this skill. Excuse me. Goodness. Alrighty. So on your first slide, you will see our success criteria. And that's why 3 more people have come in the waiting room. There we go. On that first slide, you're going to see your success criteria. I'm going to play that for us. This is a new skill and a new standard for us, but it is still working with fractions, okay? So the vocabulary will still seem familiar, but our skill is a little bit different. So without further ado, hi guys, if you are just joining us, we are on the new Seesaw activity that is just unlocked to you that is called Equivalent Fractions Exploration, and we're going to look at the success criteria right now. Here it is.
Our learning target today is to recognize and generate simple equivalent fractions and explain why the fractions are equivalent. So far, we have been using our vocabulary to compare fractions. We've been using the symbols like greater than and less than. Today, we're really going to focus on equivalent fractions. Today, you will be building a model using a fraction bar tool to make a model that represents equivalent fractions and to recognize equivalent fractions. Make sure that you are continuing to use your math vocabulary with words like numerator, denominator, parts, equivalent, as you explain your work.
Okay, so we're going to focus in on that specific of recognizing, which means seeing them, and then actually creating them. And there's a website that you're going to use to create those fraction equivalents today. Before we start, I want to take a look at a vocabulary on equivalent fractions. Again, this will give your brain some visuals and some vocabulary that will be helpful to you in today's work. So just listen, think, and enjoy.
Yo, fractions come in all shapes and sizes, and equivalent fractions, no matter how divided, are still the same sizes. You dig? It's a piece of a pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference. Piece of a pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference. Here's a chat about fractions, parts of a whole, like a slice of a loaf or a page of your notes. Fractions are equivalent when they share the same value, with two tiny differences: the numerators, denominators, numbers on top and bottom of middle line. For example, think of cake, 4 pieces in your face, and you eat it 2 today. What's left? 2 out of 4 or 2 over 4. Look at your cake, you left with 1/2 of your cake. So 2 out of 4, 1 over 2. Either way you cut it, both are the same. We can talk about pizza, you have 8 slices. You have 3 friends, so you want to be the nicest. 4 people at the table, each get 2 slices. This is 2 out of 8 or 2 over 8. 1 over 4, you can guess is the same. 1/4 of the pizza you can keep in your name. It's a piece of a pie, pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference. Piece of a pie, pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference. These fractions may look different. The fact still is that there's no difference. Every fraction has an infinite number of equivalent fractions we count are truly unlimited. Multiply the top and the bottom by the same number either way. No, the value doesn't change. Let's start with 1/2 and times it by 2. The top and the bottom are 2 over 4. We can use 3 and repeat what we do. 3 over 6, the same from before. 4 over 8, if we multiply 4, 2,000 gets 2,000 right over 4,000. We learn it all is the same. Keep it going, don't wreck your brain. Imagine we're solving a problem involving a fraction. It's best to leave it in the simplest form, meaning reduce the fraction till you can't reduce it no more. The smallest number on the top and bottom while staying equivalent to the fraction that we started with. The simplest equivalent form can be achieved. First, figure out the numbers that can evenly divide into the numerator easily. Next, do the same with the denominator. A lot of labor goes into finding what we call factors, and we only use the largest of them all. Most importantly, we take the largest factor that the denominator and numerator have in common, the greatest common factor. It's pretty easy after. Simply divide the top and bottom by the greatest common factor. Then you'll have the most reduced fraction. It's a piece of a pie, pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference. Piece of a pie, pie formed by a piece. Equivalent fractions mean the same thing. These fractions may all look different. The fact still is that they have no difference.
Alrighty. So equivalent fractions are fractions that are made with different numbers, but they are the same size. Okay, different numbers, but they are the same size. If you would please go ahead and hop back over to your seesaw assignment. Your seesaw assignment on slide 2 is where we're going to go, and you'll see that there's a not vocabulary, a brain pop video that we're going to watch. And on that brain pop video, we are going to be taking notes. Okay, so there are 2 notes there that you will be filling in the blanks with me. And we're going to take a look at equivalent fractions and what they mean. Okay, come back to you and share my screen. Guys, I am just flowing over here. All right, here we go. Here we go. So you're going to take a look at slide 2. It says take notes with your teacher. Here's what we're listening for. Equivalent fractions are blank to the same amount, but use blank numbers. So equivalent fractions are blank to the same amount, but use blank numbers. You can draw blank to help you see how fractions are blank. Okay, you can draw blank to help you see how fractions are blank. Let's take a look at our equivalent fractions here video, and we will fill in those notes when it has finished.
This sandwich has 4 equal parts. You took 2/4 of the sandwich. That's the same as 1/2. Equivalent fractions are equal to the same amount, but use different numbers. What are some fractions that are equal to 1/2? Becca and Tasha are sharing a sandwich, and each gets half. Their sandwich has 6 equal parts, so each person gets 3 out of 6 parts, or 3/6 of the sandwich. You can draw pictures to help you see how fractions are equivalent. Mike and Brian are sharing a pizza. Their pizza has 8 equal slices, so each person gets 4 out of 8 slices, or 4/8 of the pizza. 4/8 is equal to 1/2. Moby, on this rectangle, 5 out of 10 equal parts are blue. If you look at the rectangle a slightly different way, you can tell that half is blue. So 5/10 is also equal to 1/2. What are some fractions that are equal to 1/4? 2 out of 8 parts of this quilt are yellow. That means 2/8 of the quilt is yellow. If you look at the quilt a little differently, you can see that 1/4 is yellow. So 2/8 is equal to 1/4. What fraction of the tiles is green? 3 out of the 12 tiles are green, or 3/12. You can also see that 1/4 of the tiles are green. So 3/12 is equal to 1/4. What are some fractions that are equal to 1/3? It's time for dessert. This cake has 6 equal slices. 2 slices have candles. So 2/6 of the cake has candles. If you look at the cake in a slightly different way, you can see that 1/3 has candles. So 2/6 is equal to 1/3. Did you eat the candles too? There are 12 eggs, but 4 of them are cracked. 4/12 of the eggs are cracked. If you group the eggs differently, you can see that 1 out of 3 equal groups are cracked. 1/3 is cracked. So 4/12 is equal to 1/3. You're trying to glue the eggs back together? Okay. Equivalent fractions can show the same amount using different numerators and denominators. It can be a little confusing, but you can draw pictures or build models to help you understand. Not that kind of model.
Wah, wah, wah. All right, let's go ahead and back out slide, fill in those notes. Just like with our fractions on comparing, we had 2 statements that we used a lot. The greater the denominator, the smaller the piece, the same denominator, look at the equal fractions, right? So we're going to learn these phrases very well that are on slide 2. So let me show them to you. Boom. All right, slide 2. It says take notes with your teacher. We're going to add in some text boxes here. Equivalent fractions are, I'm going to make this the same size. That word equivalent is a big clue to us. Equivalent fractions are equal to the same amount, but they use different numbers. Go ahead and fill in that first line there. Equivalent fractions are equal to the same amount, but use different numbers. So we're going to be working with fractions that are that. They have the same amount shaded, the same size of amounts, but there are different numbers. So the pieces might be different size, but overall, the same size of the whole is either used or not used. Okay. Equivalent fractions are equal to the same amount, but use different numbers. You guys already know this next one. You can use, or you can draw, I apologize, draw models to help you see. You guys have been creating fraction models for quite some time now. That's not new to us. But now, instead of comparing with models, you can use models to help you see how fractions are equivalent. Okay. You can draw models to help you see how fractions are equivalent. And you'll notice that equivalent starts the same way as equal. Equivalent means equal, okay? So again, the two phrases that we're going to use a lot are equivalent fractions are equal to the same amount, but use different numbers. And you can draw models to help you see how fractions are equivalent. Okay. Two phrases that are going to be very, very, very helpful to us. On slide 3 that we're getting ready to go to, you're going to see a link to a new fraction tool. Okay, this is different from the fraction tool that we used before. So I'm going to play a short video that's going to show you how to use this fraction tool, and then I'll give you guys some time to play around with it. So this is the fraction tool that we're going to be using. It's called a fraction bar tool, and here's how we will use it.
Here is a video that will help you understand how to use our fraction bars tool. You start by going to the right and identifying the piece that you want to use. We will start by selecting one whole, which is green, and you will drag it to the white rectangle that says start by dragging a fraction tile here. Then you can grab the fraction bars or fraction strips and compare it to the one whole. When you grab a piece or a part, let's do 1/3, it will line it up for you starting on the left. If you don't line it up correctly, you can move it to fix it and show your representation of a fraction. Then you can grab other parts and line it up to compare. Over to the right, there's also a box that you can click that says show number line. If you select it, a number line will appear showing one whole. Notice our number line also goes up to 2 holes. We will not be using 2 holes today, but we'll be sticking with 1 hole as we represent fractions. On the right side, there's also the drawing tool that you can use to label fractions. And on the right side, there is the erase tool, which you can use to click and erase anything that you have done.
Okay, so that's what we're going to be using the tool today. Go ahead and on that slide 2, there's a link over here. It says fraction bar tool. When you click on that link, it's going to open you up to the fraction bar tool, and I want you to just take a minute and play around with it. So I'm just going to drag a tile and then I'm going to play around and get used to building fractions using my tiles.
Can you go back to slide 2?
Go ahead and take a few minutes to play around with those number tiles on those fractions and just get used to it. All right, so you have looked at the tool that we're going to be using. Now we're going to get some practice with using that tool, okay? Ms. Renale is going to show us how she uses this tool to solve equivalent fractions with models.
One of our learning targets is to recognize simple equivalent fractions. So let's look at an example of two fractions. I see that we are comparing 2/1/6 and 5/1/8. So far, we've been using symbols like greater than or less than to describe the comparison of these two fractions. Today, we are really going to focus on that third symbol, the equal sign. These two fractions are not equal. 2/6 is much smaller. It takes up much less space than 5/1/8. So we all know the equal symbol, but there are some other important words that will help us as we identify fractions that are equal in size. Today, we're going to use the words equivalent or not equivalent. When comparing 2/6 and 5/8, I can identify that these two fractions are not equivalent because 2/6 is less than 5/8. Here's another example. In this task, we are comparing 3/1/4 and 6/1/8. When I look at these two models, I notice that they line up perfectly at the edge. They take up the same amount of area compared to the one whole. 3/4 and 6/8 are equivalent, and we can represent it using the equal symbol. Let's do one more. Here I see 2/1/6 compared to 1/3. Are these two fractions equal? You guessed it. We would use the equal symbol to identify the relationship in the comparison. And the vocabulary we would use is equivalent. 2/6 is equivalent to 1/3.
Okay. Any questions on how we decide if a fraction is equivalent? How we decide if a fraction is the same or different size? Okay. Now we're going to, oh, yes, William.
What was the question?
If you had any questions about how to determine if a fraction is equivalent or not.
Oh, no, I don't.
All right, awesome. So now we're going to take a look at how to use that tool to create a model to do exactly that. Okay, so we've learned what they are. We've learned how to see when they line up. Now we're going to look at exactly how we use this to create it. Okay, here's how we use this model tool to create fractions that are equivalent.
One of our learning targets today is to generate or create simple equivalent fractions, or
Am I sharing my screen?
Yes.
Okay, thank you.
fractions that are equal. Our task tells us to create a fraction equal to 1/2 using 6. Show a picture of your model. Here is some important information in our text. we are going to create a fraction that is equal to 1/2 using sixths. That means I'm going to be using the unit parts 1/6 in my model. Next, I need to show a picture of my model to justify my answer. We're going to use our fraction tool today, and we're going to start by using one whole. I know that the text told me to create a fraction equal to 1/2. So next, I'm going to find my 1/2 part and move it to my model. Create a fraction equal to 1/2 using sixths. Okay, if I remember that, that means I'm going to use my 1/6 unit fraction parts. On the right, I'm going to look for 1/6. And I'm going to explore. First, I'm going to check to see if 1/6 is equal to 1/2. I can tell by my model that they are not equivalent. I'm going to take another 1/6 and move it to my model. Then I'm going to check to see if 2/1/6 is equivalent or equal to 1/2. I see that they are not equivalent yet because 1/2 takes up more area. There's more shaded space. So I'm going to take another 1/6 part. Okay. I have now identified that 1/2 is equivalent to 1, 2, 3, 1/6. We record that as 3/1/6 or 3/6. Next, I'm going to take a picture of my model. And I'm going to prove my work by putting it on my seesaw task. I have now shown a picture of my model. My last step is to fill in the comparison with the knowledge I gained. I compared 1/2 to 3/6. I learned that they are equivalent fractions because they take up the same amount of space, but they're using different numbers. This is your job today. You are going to read the task, create a model, upload your picture of your model, and record your comparison using your equal symbol.
Okay, so we're going to take a look at using this tool that we have together in our fraction strips to build models that we need to represent our equivalent fractions. All right. On slide 6, you will see the example that Miss Renale did for you. If you would like to see her example again during your independent work time, you can click on this link and it will load up the tool that we're using and you can follow along with her and do it with her. Okay. Slide 7, 8, and 9 are what we are going to complete together today. Okay. I am asking that you use this tool to create your model. I do not want to see created models that are drawn because those can be very difficult to get exactly correct on equivalence. I'm going to ask that you use the tool and upload your screenshots. Okay. Our directions say create a fraction equal to 1/2. I'm going to go ahead and highlight 1/2 using 6. I'm going to go ahead and highlight 6 as well. I have to use the 1/6 pieces to create 1/2. It says show a picture of your model. So we know already that we can fill in part of our comparison statement. We're going to create 1/2. We are also going to be using 6. We don't know how many 6 that's going to be yet, but we can fill in our denominator because it is told to us right here using sixths. Okay. So now I'm going to go to my model on my website and I'm going to create 1/2. I'm going to ask that you do the same. I'm going to drag 1/2 and I'm going to line it up with my 1/2. Go ahead and do the same.
And we did a number line.
If that helps you, for me, that's confusing because it shows 2 and we're not dealing with 2, we're only dealing with 1. So I don't like to show it. But if it makes sense for your brain, all of our brains learn differently and that's fine. But do understand that that number line is not showing 1/2. This is not 1/2. This is 2 wholes. See that? That's 2 whole candy bars. It's not a half. So be very careful with that. So we have 1/2 and we were asked to use 6. So I'm going to grab a 1/6 piece and I'm going to place it here. I have 1/6 and I still need more 6 because I'm not the same size as a half. So I'm going to add a second 6. Again, that's still not the same size because it has to be this long. So I'm going to have to grab another 6. And there we have it. You should have 1/2 and you should have 3/6. 1/2 is equivalent to 3/6. Go ahead and take your screenshot and put it on your seesaw work. 1/2 is equivalent to 3/6. Our directions tell us to show a picture of your model, so you need to show a picture of your model. Now that I know my answer, I can fill in my numerator, which is a 3. 1/2 is equivalent to 3/6. You will notice that you also have a full set of fraction bars rainbow colored over here, and we could do the same thing with our fraction bars here. If I were to shade 1/2 piece, I'm gonna make that a different color. Oops, there we go. If I were to shade 1/2 piece and then go down thirds, fourths, fifths, sixths, I would need 1, 2, 3 of those 6 to be in the same place as my 1/2. So these line up at the exact same place. I can see the proof there as well. You don't have to use that. It's just there for you if you'd like. Okay. So again, our direction said create a fraction equal to 1/2 using 6. We did that. And then it says show a picture of your model. We did that. Somebody tell me why I would send work back to you today. If you turn work into me, why I send it back to you? Because you didn't do what? Terrence?
There wasn't a question about that.
Gotcha. Hang tight. I would send work back to you if you don't do what, Christopher?
You don't do the work correctly.
Yeah, if you're not showing, if something's not correct, sure, I might give you some feedback. If you don't do all of your work, if you don't show me the model, I'm going to send it back to you because the directions tell you right here, show a picture of your model, okay? 2 of you, and I know the 2 of you that you are because we've had this conversation in the past, said your screenshot doesn't work. Here's how you solve that. There's your model. Show a picture of it. So what you can also do is grab this, unlock it, make it bigger, and use that for your model. Okay, so you have that right there. So there are no excuses not to have a model. Questions on that? William?
No.
All right. Sorry, I saw your hand. Okay. Let's take a look at the next one on slide 8. Get some more practice together. Remember, I am not available to you for work time. So if there is something that is not making sense to you, now is the time to ask. Okay? Create a fraction equal to 3/4. I'm going to highlight 3/4. Using eighths, I'm going to highlight eighths. I have to use the 1/8 pieces. Show a picture of your model. So what I know is I am going to be creating 3/4. How do I know that? Because it's right there in the problem. 3/4. I am going to be creating an equivalence using eighths. How do I know that my denominator is 8? Because it says eighths right there in the problem. Questions on that so far about why it's 3/4, why it's eighths? Okay. Terrence, is this about the 3/4 and eighths, or is this your thing from earlier that was going to be later?
Earlier, but it's still for math.
Okay.
So, I don't get why that other slide was equal, because the pieces were smaller, but it was the same length.
That's exactly why you just said the answer, because it was the same length. So here's an example, Terrence. Oh, I got to stop sharing my screen because I forgot you can't see me. Okay, here's a Post-it, right? Here's another Post-it. These are the same size. Okay. If I give you one hole, there you go. You've got a Post-it. Okay. Now, if I do this for me, I still have a Post-it, right? It's just in 2 pieces. Watch. Boom. So these are smaller pieces, but they are the same amount of material. So if I put these back together, I've still got a full Post-it that's the same size. It's just in smaller pieces. Okay, so it's understanding that fractions are the same total length. Even though the pieces are smaller or larger, the total length is the same. Does that make sense? Awesome. All right. Thank you for asking and clarifying. So let's continue up here with slide 8. Now we're going to create our model. Okay, so William, I know your screenshot doesn't work, so you can unlock this, you can make it larger, and then you can use 3/4 and eighths. Okay, the rest of you, your screenshots work. All right, so we're going to go to this link here, and we're going to create 3/4 and we're going to create eighths. I always like to compare the size to one whole, so I always start with a whole so I can see that it is in fact smaller than a whole. Our first fraction was 3/4. Drag 3 of those fourths and line them up in a row going straight across. So this is my 3/4. Our directions told us to use eighths. So we're going to grab those 1/8 pieces to create our equivalent fraction to 3/4. Okay, so I'm going to go down here and I'm going to drag an eighth. It's pink. I still need more 1/8 pieces because it's not the same length as all 3 of my 1/4. So I'm going to keep adding them until I get them at the exact same length as the 3/4 up top. There's 4 1/8, 5 1/8, and 6 1/8. Okay. I now have 6/8. So the number of eighths that I would need to be equivalent to 3/4 is 6. I need 6 1/8 pieces. I'm going to take my screenshot. You're going to do the same thing. And we're going to upload it to Seesaw on that slide. I'm going to erase these arrows that I drew because those are not necessary for my answer. And then I can add my picture. Again, I will be sending your work back to you if you do not show your model. Okay? It tells you in the directions to show your model, so you are going to show your model. And now I know that my numerator is 6, and I can fill in that 3/4 is equivalent to 6/8. So each slide should have a completed statement with an equivalent symbol. Each slide should have a picture of a model. Okay. We are at the end of time, so here's what's going to happen. If you feel like you need more practice, you can stay on with me and we'll look at slide 9 together. If you don't feel like you need more practice, you're going to log off for lunch. After lunch, you're going to come back and work on your independent work slides. Slides 11 through 16 are exactly what we've just done. They give you a fraction to build. They give you a piece to create. These say any unit, so these give you free choice. On 15 and 16, you can use any piece that you like. On 11 through 14, they tell you the name of the piece they want you to use. 6/8, thirds, and fourths. Okay, you're going to do exactly what we just did together. I will see your comparison statement of equivalence. I will see your model, and then you'll click that green check to turn it in. Okay. Any questions before I release you? Okay, see ya. All right, so let's slide 9, gentlemen. Go ahead and mute, baby.
You can go back to slide 8.
I'm gonna go back to slide 8. Animal. There you go. Go ahead and mute for me, baby. You're getting a lot of feedback.
Okay.
Thanks. Justin, let me know when you're good with slide 8.
I'm good.
All righty, let's take a look at slide 9. Slide 9 together asks us to create a fraction equal to 1 whole. I'm going to highlight 1 whole. We are to create a fraction equal to 1 whole using halves. Okay. So 1 whole as a fraction, we know that when we have a whole, the numerator and denominator are the same. So 1 whole is 1 whole, 1/1. When we are creating halves, our denominator is 2 because halves have 2 pieces. Okay. Now we're going to take a look at that model. So I'm going to use my link here to create a model. I'm actually going to get rid of those other links of one whole and see how many halves I need. Okay. So we're going to grab one whole, and that's actually the fraction that we're starting with. So we've got one whole. We were asked to use halves, so I'm going to grab a half, and I can see that that is not as long as my whole bar. So I'm going to add another half. And now I can see that these are the same size. They start and stop in the exact same place. So I need 2 halves. 2 halves is the same as 1 whole. Go ahead and take your screenshot. What I wanted to do. Here we go. How strange. And then we're going to upload that to Seesaw. I now know my answer for my numerator is going to be 2. 1 whole is equal to 2 halves. Okay. Any questions on that, gentlemen? Go ahead and feel free to unmute. Okay, so that's what you're going to do today. You guys will have the opportunity to complete this during your independent work time this afternoon using that link.